Hey, we are back with 7.5, solving quadratic equations using the quadratic formula. Not gonna lie, quadratic formula, love it. It is the bomb. So before we start and go ahead using the quadratic formula, we're going to define a couple of things. So for starters, we're going to talk about roots. We've already kind of mentioned what roots were when we were introducing x-intercepts. But we are going to define it once more just for the people in the back here. So roots are the values of the variable that make an equation in standard form equal to 0. AKA, we are trying to figure out what the values of x are when y equals 0. So we're really just looking for the x-intercepts. Okay? So, our roots, well, these are also called solutions to the equation. Sometimes they're called zeros of a function, or they could also be called x-intercepts of the graph. So they go by various names, but they all refer to the same thing, just a little bit in different contexts. So we call them x-intercepts if we're talking about a graph. We call them zeros if we're talking about a function. We call them solutions if we're talking about an equation. But we could also call them roots. All of these refer to the same thing. We are looking for the value of x when y is equal to 0. Okay? So the quadratic formula is a formula, believe it or not, for determining the roots of a quadratic equation in the form y is equal to ax squared plus bx plus c, where a is not allowed to equal 0. So this is the standard form that we were talking about of the quadratic formula. And when we are looking for the roots, the x-intercepts, we can use the quadratic formula below. And you might be thinking, holy bananas, how am I ever going to memorize that? First of all, you might very well memorize it. I know I have it drilled into the back of my mind, mostly because I love it, and how could you forget your one true love? But also because you happen to use it quite a bit. But if you don't happen to memorize it, that's okay too. It is on your formula sheet, so it is something that you will be provided if need be. If you're wondering where this formula came from, this formula is actually derived. This formula is derived from our ax squared plus bx plus c is equal to 0 by isolating for x. So technically, you could very well derive that yourself, but you will never be expected to in this course, so don't worry too much about that. But this formula we are going to be using quite a bit. It is super useful. It is awesome. Like I said, I absolutely love it. And we're going to practice learning it together. So one thing that I will ask that you have with you is your graphing calculator. You won't be graphing, but you'll be going through quite a bit of calculations, and I want to make sure you can plug them in properly. A lot of people have difficulty in plugging things into their calculator because they either forget the brackets or they make little simple mistakes. They try to plug it all in at once. So sometimes this can be pretty difficult. So as we're going through things together, what I would absolutely love is if you could have your calculator with you, go through these calculations to make sure that you know how to do that. If you get any numbers that are different from what I get, then send me a message, come talk to me. We'll figure out what happened together, but make sure that you can plug them in all properly. All right, so we are going to be using the quadratic equation to solve for x. Okay, our quadratic formula, like it says above, is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And I realize that this is a little bit long. I'm going to draw it a little bit smaller. All right. What we do need to know, make sure that we kind of have set in our mind, is what is our a value, what is our b value, what is our c value. I often like writing that off to the side just so that I'm sure that I'm plugging everything in properly. So here a is this positive 6, b is this negative 7, and c is this negative 3. Okay. So we are going to plug in all of these values into our equation as we go. What we're going to do is we're always going to plug things in brackets. Okay. Very often when people plug in negative values, they plug them in incorrectly, especially if there's a negative already in front of it. So to prevent us from doing that, we are going to make sure we plug in everything in brackets. So into this equation here, every time I see an a, I'm going to put a 6 instead. So I'm going to get rid of this a, going to get rid of that a, and I'm going to put in a 6. Same thing. Every time I see a b, I'm going to put a negative 7. Negative 7. Negative 7. And you might notice, where'd my yellow go here? You might notice that if I didn't plug in negative 7 in brackets, it's really easy to think, oh, I already have a negative there. So it'll be negative 7. But in fact, when we simplify that later, it's going to be negative 7, which is a positive 7. So that's a really easy mistake that's made. And then lastly, instead of c, we're going to plug in negative 3. So this is what we should have when plugging into our equation. Now we are going to go ahead and start simplifying some of these values. So we have x is equal to negative 7, which is positive 7, plus or minus the square root of negative 7 squared. Negative 7 times negative 7 is positive 49. And negative 4 times 6 times negative 3 will give us positive 72. All divided by 2 times 6, which is 12. Okay. From here, we have 7 plus or minus. Underneath our square root there, we have 49 plus 72, which should give us 121, and still divided by 12. The square root of 121 is 11. And this is where we get up to. What I want you to draw your attention to right now is in this equation we have this plus minus. That is because we are looking for quadratic equations that can have up to 2 x-intercepts. One of those x-intercepts can be found by doing 7 plus 11 divided by 12. The other one can be found by going 7 minus 11 divided by 12. So we actually have to split these up into 2. So I'm going to split one up there. I'll split the other one up here. I don't like that arrow though. All right, so purple. So here I'll put x is equal to 7 plus 11 divided by 12. And on this side I'll go 7, or x is equal to 7 minus 11 over 12. Okay. 7 plus 11 gives me 18. And 18 over 12 is 1.5. And on this side, 7 minus 11 gives us negative 4, and negative 4 over 12 gives us negative 0.33, assuming we're rounded to 2 decimal places here. Okay. So looking at this, our values of x that make this equation equal to 0 is 1.5 and negative 0.33. Okay. So these are going to be our x-intercepts, our roots, our solutions, our zeros to our equation. And just like I said before, because we are finding our roots or solutions or zeros or x-intercepts, technically, we should be able to plug in that same equation, except instead of 0, we'll put y is equal to 6x squared minus 7x minus 3, and get those exact same x-intercepts, which we do. We get x is equal to 1.5 and x is equal to negative 0.33. Okay? So we can always double check that our answers are correct using Desmos, but when we're using the quadratic formula, you do need to make sure that you show all of your work and things like that. So this is how we would use the quadratic formula. It's absolutely wonderful. We could do everything algebraically. The nice thing about this is sometimes these quadratic functions that we're given, or the quadratic equations we're given, sometimes we could factor them and then solve by factoring. But sometimes they're not factorable. They give us a lot of weird decimals, and we're not able to figure out those answers on our own. And the quadratic formula is really, really good for that. Okay, so we are going to continue on with the quadratic formula. I'm not going to check every single answer with Desmos, but you are more than welcome to make sure that we get the same thing. But all of our answers here, our x is equal to our 1.5 and the negative 0.33, represent the x-intercepts on the graph. All right. So we are just going to keep cruising. We're going to see different examples. We're going to try different things. We're going to get some different numbers. Sometimes they're going to be weird. Sometimes they're going to be normal. Life will be good. So for starters here, we have a is equal to 12, b is equal to negative 47, and c is equal to 45. Right? For our quadratic formula, we have negative b plus or minus b squared minus 4ac all over 2a. And we are going to substitute those values in. Instead of a, we're going to put 12. Instead of b, we are going to put negative 47. And instead of c, we are going to put in 45. We always plug those in with brackets around so that we don't mess up with things like this where we have the minus the negative. Okay? So when we are going here, we are simplifying. So minus negative 47 gives us 47. Negative 47 squared gives us 2,209. Minus 4 times 12 times 45 gives us 2160. And then we're dividing it by 2 times 12, which is 24. Okay. Next step is we are just going to combine what's underneath our radical sign here, which reduces actually to 49. And we're going to do the same thing. So we're going to plug in the square root of 49, but we should know what that is. Oops. That's just straight up 7. And we end up with the same spot here. Because we have that plus or minus, we do have to separate into two possibilities here. So we could have x is equal to 47 plus 7 over 24. Or x is equal to 47 minus 7 over 24. If we look on the plus sign here, we've got 47 plus 7, which gives us 54 divided by 24. And x will give us 2.25. On the right-hand side here, we have 47 minus 7, which is 40. divided by 24, which will give us 1.67. Again, assuming we're rounding to 2 decimal places here, which is going to always be our given. And there we have it. So far, we have always been given these beautiful, just gorgeous numbers, right? We've had the square root of 49. We know what that is. We've been given the square root of 121. We know what that is. But what we might not be so comfortable with, but doesn't really change much, is that we could sometimes get to values that aren't these perfect squares. And there's nothing wrong with that. It shouldn't freak us out. It is the way that life goes. And we can work with it the exact same way. So no worries here. So let's try an example where that happens. So here I have A is -2, B is 8, C is 5. And we're going to plug that into our quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we're going to start plugging things in. Instead of a, we're going to plug in -2. So -2 over here, -2 down here. Instead of b, we're going to plug in +8. 8. And instead of c, we're going to plug in 5. And I'm always plugging things in brackets here to make sure that I'm not goofing up with any of those negative or positive signs that occur. Okay, we're going to start by simplifying some things. So -8 plus or minus 8 squared is 64. -4 times -2 times 5 should give us +40. And 2 times -2 gives me -4. On my next line here, I can figure out what 64 plus 40 is. That gives me 104. And this is what we're talking about, is that before we had these beautiful square numbers that we knew the square roots to. But 104 we don't know the square root to. In our calculators, when we go ahead and figure out the square root, we get this decimal that continues on. And it's irrational, right? Because it is not a perfect square. So we get 10.198 and so on. Okay? When we do the square root of 104, we should be storing that value into our calculators, right? So if we go the square root of 104 and then we hit enter, it should give me 10.198 and so on. We should hit that stow button and then store it into our x. Okay? And then that way, every time we want to use that number, we're using every single decimal value, so we're not rounding too soon. Right now, it's not going to affect us hugely if we round to maybe 3 or 4 decimal places now, and then round our final answer to 2 decimal places. But especially when we get to like grade 12, and especially when we do our first unit in grade 12, rounding becomes very, very key. So we always want to store those values if possible. So making sure we store it as we go here is going to be super useful. If you don't feel like writing out the whole number as you go, I usually get away with just writing maybe the first 3 decimal places and then going ... assuming that I'm continuing to keep all of the decimals that follow. That is something that you're able to do if you so desire as well. But please make sure you're storing that value into x and using that whole number. Okay? All right. So, from this point on, we are still breaking things up as we would before. Right? So, on one side here, we'll have x is equal to -8 plus my 10.198 and so on, divided by -4. And on the other side, we'll have x is equal to -8 minus 10.198 and so on over -4. Okay. On this first equation here, so when I go -8 plus 10.198, I get 2.198 and so on, divided by -4. And when I divide by -4 and I round to 2 decimal places here, I get -0.55. On my other side, if I get negative 8, subtract 10.198, dot, dot, dot. I get negative 18.198, dot, dot, dot. And when I divide that by negative 4, I get 4.55 if I round to 2 decimal places here. And again, those will be my x-intercepts. So if I plug this equation into my Desmos, and instead of 0, I put y, I will find that those are to my 2 x-intercepts. Okay, so that is what the quadratic formula finds us. It finds us the zeros, the roots, the x-intercepts, the solutions, which are all essentially the exact same thing, but just different words that we use for different contexts. All right, last one on this page before we get into word problems. And here we have our a value of 1, right? Because if there's no number in front of it, we assume that's a 1, not a 0. Because if it was a 0, we wouldn't have that term at all. B is equal to 2, and C is equal to 3. Nice numbers. We have our formula. X is equal to negative b plus minus the square root of b squared minus 4ac, all divided by 2a. Instead of a, we write 1. And again, I always plug things in brackets here to make sure I don't make any mistakes. Instead of b, I write positive 2. And instead of c, we write 3. All right, starting our simplification journey. So negative or minus 2 will give us negative 2, plus or minus the square root of 4, or 2 squared, which is 4, minus 4 times 1 times 3, which is 12, all over 2. We have negative 2 plus or minus the square root of negative 8 over 2. Whoa! Radicals. What you might remember from last year, if you try plugging this into your calculator, it is not possible to have the square root of a negative number without involving imaginary numbers, which we are not doing. So you cannot take the square root of a negative number. This is a big no-no. Even if you tried, your calculator should give you an error message. Okay? What this means is that there are no x-intercepts. So there's no roots, there's no solutions. Oh, that's kind of ugly. Solutions. There's no x-intercepts. So our graph is one that does not have any x-intercepts. And just for the sake of really driving this point home, let's graph it on Desmos here. Okay, so if I put y is equal to x squared plus 2x plus 3, notice how it never hits the x-axis. So we can't find x-intercepts. We get this error message because it doesn't exist. So if you end up with the square root of a negative number, that doesn't mean that you've done something wrong. It just means that the math isn't possible because there is no solution. Which is kind of cool. Anywho, so that is a little bit of the quadratic formula, right? We could do the quadratic formula with these nice numbers like we had in A, where we had this beautiful square root of 49. We could use the quadratic formula with these irrational numbers, right? The square root of 104, that's fine. And we could use a quadratic formula when there's no square root at all. So we can use it for literally anything. Factored form is, you could use it for a good chunk of things, but only if those roots are really perfect. So otherwise, it doesn't work out all the time. Vertex form, it's hard to convert to that point unless you're given the graph or you're given that equation. So it's not always the greatest, but the quadratic formula will never fail you. And this is why I love it so incredibly much. So what we're going to do is we're going to look at these next two word problems. The first one here is we have Tiana. She's standing on top of a tall building. And she has a paper airplane, and she throws it on the top of the building. And we have Y here that represents the height of the paper airplane above the ground in meters. And X represents the number of seconds after the plane is thrown. It can be represented by the following quadratic function. So here we have this quadratic function where Y represents the height, X represents the time after it's thrown. And it's asking us how long will it take for the paper airplane to reach the ground below. Solve using the quadratic formula. So, when does the paper airplane hit the ground? Right? The airplane hits the ground when the height is 0. Right? The ground is at the level of 0 meters, so when the plane hits the ground, the height is 0. And since height is represented by Y, we are solving for X when Y is equal to 0. Right? And we know how to do that, right? Because if we plug in 0 for Y, we get negative 4.9 x squared plus 4x plus 125. Well, this looks almost identical to what we had on the previous page. This is our equation here. Here we can go ahead and go A, B, and C. Figure out what those values are. So A is negative 4.9. B is 4, and C is 125. And we can go ahead and plug those into our quadratic formula and solve for X. So, we have X is equal to negative B plus or minus B squared minus 4AC, all divided by 2A. Well, same as before, instead of A, we are putting our negative 4.9. Instead of B, we're putting 4. And instead of C, we're putting 125. Okay. From here, we're just going to work by simplifying things. So negative 4 is negative 4. Let's backtrack here. 4 squared is going to be 16. Negative 4 times negative 4.9 times 125 will give us positive 2450. And all divided by negative 9.8. We could go ahead and simplify some more. We have negative 4 plus or minus the square root of 66. And we could again simplify some more by plugging in that square root, and we should get 49.6588 and so on. And again, we are plugging that 49.6588 and so on into our calculators with the store button so that every time we want to use that value, we just hit X. Okay? And we're dividing it by 9.8. From here, we still have to split it up. So, we could split it up here and here. So we could have negative 4, don't forget my X here. X is equal to negative 4 plus my 49.6588 and so on, divided by 9.8. And we could have X is equal to negative 4 minus 49.6588 divided by negative 9.8. If we focus on that first one, or that top one first, we get X is equal to 45.6588 divided by negative 9.8, and we get x is equal to negative 4.66. If we focus on the bottom one here, we get x is equal to negative 53.6588 ... divided by negative 9.8. And rounding to 2 decimal places, we get 5.48. Now, this is a word problem, which means our answers have to make sense. Do they fit within the context of the question? Remember, the question is saying, how long will it take the paper airplane to reach the ground below? Does it make sense for us to say it'll take negative 4.66 seconds? No. We cannot say something will take a negative amount of time. So we can't have a negative time or a negative amount of time. This is not possible. So this is not a possible solution in this word problem. Okay. Keep in mind that when we're not doing word problems, negative answers are totally okay. In some word problems, negative answers will also be okay. But in this specific one, because x is being representing the time after I threw the airplane, it doesn't make sense to say how long until it hits the ground, negative 4.66 seconds. Our final answer has to answer the question. So it says, how long will it take for the airplane to reach the ground? It will take 5.48, and we need to make sure we use our units, seconds, because that's what our units are, for the airplane to hit the ground. Actually, that's just really ugly. I don't like that. We'll resort back to my pink boxes. All right. So that is our final answer. And again, we can use Desmos to verify our answer. We have y is equal to, or negative 4.9x squared, 4.9x squared, plus 4x, plus 125. Okay. And here we have it 5.478, no, 5.475, which rounds to 5.48. And then we have our negative response, which doesn't make sense in the context of this word problem. Okay? All right. We have one more word problem, and then we are done this section here. And we have it talking about the moon. The moon's gravity affects the way an object travels when it is thrown upwards. Suppose that you threw a ball upward from the top of a lunar mound that was 5.5 meters high. The height of the ball, y, in meters, over time, x, in seconds, can be modeled by the function. How long will it take for the ball to hit the surface of the moon? Solve using the quadratic formula. All right, so we are starting off with the same thing. We want to figure out when the ball hits the moon. So the ball hits the moon when the height of the ball is 0. When height is 0. Since y represents the height, we want to solve when y is equal to 0, which means we are solving for x, which is represented by the time. So essentially we are solving for 0 is equal to negative 0.81x squared plus 5x plus 6.5. And we have our a values of negative 0.1, or negative 0.81. We have B is equal to 5, and C is equal to 6.5. Okay. We are using our quadratic formula to solve for our values of x, just as we normally would, and life is good. Before I go ahead and start doing this with you, what I would love is if you can pause the video. If you want to wait until I finish writing out the quadratic formula so you don't have to flip back, then fantastic. But I would love if you could pause the video and see if you could solve this word problem on your own, and then resume the video and see if you are on the right track. All right, pause. Welcome back. I'm glad you came. Okay, so from here, we are replacing our A's with negative 0.81. Negative 0.81. Okay, we are replacing our B's with 5. And we are replacing C with 6.5. And then we are going to just work and simplify. Minus 5 is negative 5. 5 squared is 25. Negative 4 times negative 0.81 times 6.5 will give us positive 21.06. And 2 times negative 0.81 gives us negative 1.62. Simplify some more inside our radical. We get 46.06. And if we go ahead and plug that into our calculator, we get 6.786 and so on. We are hitting store on that 6.786 ... value and saving it into our calculator so that we could use the whole value there. And then we are going to split it up into what would happen if it was positive, what would happen if it was negative. Okay. We are continuing. So we got x is equal to negative 5 plus 6.786 ... divided by 1.62. And x is equal to negative 5 minus 6.786 ... over negative 1.62. If we continue with our top guy here, we end up with 1.786 ... divided by negative 1.62, which gives us negative 1.10. If we continue with the bottom one here, we get negative 11.786 divided by negative 1.62, which gives us 7.28. Again, we need to make sure that our final answers make sense. So having our time for the ball to hit the ground to be negative 1.10 seconds doesn't make sense. Time can't be negative. So this is not possible. This is not our solution. Which means our final answer will be this one here. It will take 7.28 seconds for the ball to hit the surface of the moon. And that is our final answer. It will take 7.28 seconds for the ball to hit the surface of the moon. All right, so we hopefully feel pretty good about the quadratic formula. Hopefully with word problems, we know that we have to ask ourselves, does this solution make sense? Because we have a couple of questions for you to do below. Okay, so give it a try the 7.5 homework, and then when you come back, 7.6, that is the last section of this unit. All right, ciao for now. Bye.